Welcome to Sean White's Solar and Energy Storage Podcast. This episode is going to be about the history of PV, the present of PV, and the future of solar PV. Hey, does that remind you of the Scrooge? Remember? Christmas past, Christmas present, and Christmas future? Well, hey, we are in the future compared to 1 second ago. So what we're going to talk about here is PV markets and applications, the NABCEP exams, Edmund Becquerel, who discovered the photovoltaic effect, and then there's Einstein, who discovered the photoelectric effect. That's a Nobel Prize winner. Then there's PV flash testing, Bell Labs, the Vanguard 1 solar satellite, the world installed capacity of PV getting to 1 terawatt of PV installed capacity, hockey stick PV growth, space-based solar power, that's SBSP, and that brings us to the Dyson sphere. We're going to talk about Swanson's law, which is often compared to Moore's law with a computer chip, PV being $77 a watt in 1977, kind of easy to remember. Solar PV and eclipses. So when there's an eclipse of the sun, how does that affect the grid? Guerrilla solar installations, perpetual solar flight, and the solar impulse. On with the show. Markets and applications. Some history part of the applications. Kind of interesting stuff. You could see a little bit of this on the NABCEP exam. So first of all, there's a guy named Becquerel. There's actually a Becquerel Prize in the photovoltaic industry for people that are smart geniuses. And when he was a teenager, at 19, barely a teenager, he discovered the photovoltaic effect. And that's what we are using when we are making energy from sunlight with semiconductors. What he did, though, in his time is he put electrodes in a solution, and when they were exposed to light, it made a little bit of electricity, a little bit of voltage. And it wasn't a whole lot. There was no practical applications at the time. It was more like a magic show. And that was Edmund Becquerel, is what we call him. And then Einstein. A lot of people don't know when he got the Nobel Prize, it wasn't for E equals MC squared. It was for PV pretty much, or we call it the photoelectric effect. Some scientists will argue that it's a little bit different than PV, but pretty much what it has to do with is light hitting something and knocking electrons loose. That sounds like PV to me. And that's what Einstein got the Nobel Peace Prize for. One thing that was kind of interesting is one time I was doing a class in Shanghai, and I looked at an article and I noticed that there's a different hotel that Einstein was in when he got the Nobel Peace Prize. And it was called the Astor House Hotel. And so I immediately changed hotels, and I went and I stayed in the Einstein room, which cost a little bit more. It had his picture all over the place. And over in the Einstein room at the Astor House Hotel, I found little pieces of Einstein. I cloned him. So I have myself a little Einstein. So to sum it up, in 1905, Einstein wrote a paper explaining the photoelectric effect. Then, when he was going through Shanghai at the Astor House Hotel in 1922, he was notified that he had won the 1921 Nobel Peace Prize. And I got to stay in his room. I also used to know one of his relatives. We celebrated our birthdays together. She was a huge Trekkie. Okay, PV history, 1954. Bell Labs came up with the solar cell. So think of Bell, telephone, helicopter inventors, and all that. And they called it a solar battery. It looks like a module. They called it a solar battery, but solar modules do not store energy at all. They can do a flash test on a PV module and a flash of light, and they can tell all the specifications of that module because pretty much the electricity travels just about the speed of light, and that is fast. They are using solar module to charge a battery. Back in the day, it was really expensive, like super crazy expensive. Some people thought it was going to change the world a lot sooner than it did, but it is actually changing the world today, right now when you're taking this class. Solar is taking off like crazy, doubling all the time. Bell telephone system, so they were using this for telephones because they were using the solar for repeater sites and places where they couldn't run power lines, where it was too expensive. And they used to use them for small water pumping systems. They would use them on flashing lights for actually the oil companies for a while kind of kept the solar industry going when they had solar modules up on top of their rigs, making those lights blink so you don't crash your airplane into it. So don't crash your airplane into an oil rig. It's a bad thing. I recommend, especially if you like space stuff like I do, and aviation like I do, you can go to the Washington, D.C. Dulles Airport, and I had a layover, and I made sure it was as long as I could make it. And I went all through satellites that are solar powered and everything, all kinds of awesome things, lots of NASA stuff too. So I recommend you go do that. Go do that right now. That's your homework. Extra credit. Okay, and going from history into the present, it is time to look at the world installed capacity of PV. What I suggest you do is just go into Google and do a search for that, because it is so hard to be current on this topic. For one thing, we don't always have data for this year or even the year before, because they have to compile the data. So you go on there and you check and see how much PV was installed in the world. We will probably be at 1 terawatt, that's 1,000 gigawatts. That's 1 million megawatts. That's a million watts. That's a trillion watts. That's a lot of watts. We might have already hit it. So look out for that in the news. PV capacity installed in the world hitting 1 terawatt. In the 2020s, the growth is really one of those hockey stick curves where it goes up and up and up and almost looks vertical as you get to where you are in the present. And that's because every time we go up, we're increasing by tenfold. So we're 1, 10, 100, 1,000. That's a huge increase that we have. And that's the growth of solar. That's what we're seeing. One time I did a calculation, and I wanted to figure out how long with this kind of growth will it take for solar to cover the entire planet, so that the entire planet of Earth would be one giant solar ball. But we know that's not going to happen, because we're not going to do that to our planet, and we might end up putting solar in space. And a lot of people are designing solar space stations. So 24-hour sun goes up to space with the PV, microwaves it down, has microwave receivers, and then it goes to the city. Very interesting stuff. And a lot of people think that this is going to be the future. That's a good way to get 24-hour solar power, which reduces our need for things such as energy storage. I wrote an article on space-based solar power and got to interview the CEO of SolarN, and was in the Solar Today magazine published by American Solar Energy Society. Not too hard to find on a Google search. And then if that growth keeps on going, you could potentially end up with something that we see in science fiction called a Dyson sphere. Just remember, if we go to the past and look into the future, which is now, it looks a lot like science fiction. Captain Kirk talking on his flip phone. Even think about how not long ago, we couldn't even fly an airplane till the Wright brothers came along in the early 1900s. And it wasn't too long after that there were people on the moon. So in 1903, the Wright brothers discovered the airplane. And in 1969, humans stepped on the moon. That is only 66 years later. So some of these things that sound crazy turn out to be reality. On with reality. In today's world, Swanson's law postulates that for every time you double the amount of PV manufactured, the price goes down 20%. And that's what drives the industry. Cheap PV. Nobody could have ever imagined. Except for this guy, Dick Swanson. He's the sun power guy and came up with Swanson's law, and he says that he didn't really come up with it. It was another observation that he saw that somebody else made about technology. And as you increase technology, the price goes down with mass production. In 1977, just the solar cells themselves were $77 a watt, and now they are super cheap. And one last interesting thing is what happens to solar during an eclipse. It went totally dark. You could see stars in the middle of the day, and the PV system turned off for a little bit. Every time there's a total eclipse, there's articles out there saying that it will crash the grid. It doesn't crash the grid. Everything turns out just fine. But if it's not an eclipse, if it's just clouds and rain clouds, even on the darkest day, during the day, when the sun is up behind the clouds, you're going to get something. It's not going to turn the PV system off. One last thing before we finish this PV history lesson is let's take a look at the past, which was 2002. There was a magazine that you can no longer get called Home Power Magazine that most people used to use to install their solar systems with to figure out all the information. And person, they call them a solar enthusiast or a guerrilla solar person. So back then it was illegal to feed the grid. This person took 4 solar modules and made a solar panel out of them with 4 modules that he put together, making a solar panel, and that equaled 240 watts. That's 60 watts each. Nowadays, one module is almost always going to be over 240 watts. and then he fed his grid. This guy is still probably trying to pay off his system because it cost so much back then. And then not too long, just 8 years after that, we have perpetual solar flight. And that's not just solar flight, but manned solar flight. That's the solar impulse. I actually met one of the pilots. And then, of course, we were already talking about space-based solar power. So I hope you enjoyed this history lesson. Thanks for listening to Shaun White's Solar and Energy Storage Podcast. You can find out more at solarsean.com.